So we're looking at network addresses today, and it's quite handy because you can link it into postcodes. Andrew quite likes, don't you, Andrew?
I think it's a good way. It's a good way of exploring how networking works with something that we all already kind of know.
Yeah, definitely. So we have myself, Bryony, today, and Andrew. We are going to take you through this pre-recorded webinar, slightly different to how we normally do them. Please, Andrew can edit it a little bit more. So why do we need postcodes? This is difficult to do. Usually you expect somebody to shout an answer out here. Andrew, why do we need postcodes? You can be my audience.
Well, once upon a time, the post office relied on the local postmaster or mistress knowing who everybody was. And then, obviously, as the population grew, more towns appeared and more roads appeared. That became very difficult. And then, as they started creating sorting offices, they needed a system so that the post trains, the post vans, and the post women and the postmen could find the street that we live in.
Yeah, it would have been great to do. Now that's a bit impossible, isn't it? We've grown so massively that people can't know that information. And it's the same with our networks. Our networks would have started off small, and now they're ginormous. You can't know all of that information. So postcodes give us lots of information, but maybe not everything. We need some extra information as well, like our actual street and our number. The bigger the city you live in, the bigger area your postcode covers. I can imagine if you live somewhere down south, that it would be a lot harder to know where everybody stays without having that additional information. I like this picture, Andrew. It's very relevant.
It is.
So let's see our networks, and we have a lovely map example here of different areas, different postcode areas, and that's similar to how a network functions as well. Our network address gives us an area or a section of that network, and within that we then have additional information that helps us pinpoint all of the additional bits and pieces that we need to know to be able to route our information. Very specific postcodes in here you want to talk about, Andrew? I know you know this bottom of the country better than I do.
I do, yes. I mean, from a sorting perspective, the post will go to a big sorting office in an area. I was born in the TA area and I grew up in the BA area, right in the middle right hand. And you get to know then different sort of towns just from the code. So BA16 or BA16, if you look it up, you'll actually find the town that I grew up in. But I'm not going to give any more information away than that, because obviously, yeah, you can start trying to work out other personal and confidential information and maybe my passwords and stuff like that. But we all live in those areas. So if you look up SW1 in London, it's a very well-known area and it's got some quite important buildings and organisations in. And by doing that, the post office enables themselves to send the post mostly to the right place most of the time. When you think of the millions and billions of letters they send each year, or we send each year and they deliver for us, actually, yeah, very little gets lost in the system. And around the world, of course, we've got zip codes and other postal addressing systems. Back over to you, Bryony.
Just on that point, if I am initially from SK, but you will struggle to find information specific about what town I came from, because in Scotland, SK covers a massive geographical area. So a little bit harder. And talking about does post get lost, you touched on that just there, Andrew. Yeah, things do get lost. Sometimes your post comes in one of those plastic bags to say something's been damaged on the way, or somebody's opened your birthday card and stole your money. That's down to human error. It could be machinery. It could be that you put it in the post box and it's got shoved down the back of it and you've forgotten to see. It could be because they can't read your handwriting, which is a definite problem in the world. I spent last week writing on a board and nobody could read my handwriting. So we rely on humans and we rely on people to be able to decipher what is going on. So things do get lost, and that happens in our networks as well. If any of you have looked at Packet Tracer already and had a little play about with it, and we're going to talk about it in a second, you can send packets across that network and it won't send the first time because Packet Tracer hasn't had a chance to catch up or switch itself on properly. So things do get lost. And then from that, we need to be able to address our networks in a way that we can send our information effectively. So we have devices that will help us with that. I'm just going to do a little demonstration soon and show you it all working nicely. So we need to know, or our network needs to know, where do we send all of that traffic? It needs to know where is it coming from as well. Same thing as if you're getting a delivery or a letter. You should really have your sender and your receiver on there. It makes things a lot easier. It means if it does get lost, it can get sent back to the sender. So we have network addresses, which give us our postcode of that network. We have our host addresses or device addresses, which is all of our individual elements connected to our network. Like, for example, in this diagram we've got here, we've got a PC. So that could be a laptop or a phone. And we have broadcast addresses as well, which we like to use to send information out to everybody. So network addresses, oh, sorry, I have to think here. Network addresses work by allowing our routers to learn that map of that network and where to send things. They do lots of smart things in the background. There's some algorithms that I can never remember how to say the names properly, and maths pretty much to work out where things need to go. They'll also make changes if there is changes to the network, and they will think about or know if there's any issues on that network as well, and send things in alternative routes. So it's a little bit like if you are relying on any sat-nav system on your phone to navigate yourself around a city. It will send you the best routes dependent on the traffic. Fingers crossed, Andrew's right. I spent my week in Manchester last week for the first time and spent most of my week getting lost and ending up in the wrong restaurants. Andrew, were you a bit more successful than I was in navigation?
Years of practice, and also I'm used to the city centre of Manchester. But yes, basically routing protocols or network routers, a bit like the post office knows which area to send it to. They'll have their own transport network and work out the best route. Internet routers will also work out the best route using an algorithm.
Yeah. And then on that note, we have a lovely packet tracer file, don't we, Andrew, that demonstrates all of this.
Okay, so I'm going to start sharing now. So this is the bit where I ask Bryony if you can see my screen. Can you see my screen, please, Bryony?
Yeah, definitely can.
Right, so I'm going to put this network up on the portal for CyberCamps later today, so you can actually have a play and explore with this. Basically, what I've done is I've built a free router network, the Ada Lovelace, the Marie Curie, and the Hedy Lamarr networks, using some classic addresses. I'm not going to explain all the details of the addressing, but what I haven't yet added is something called a routing protocol. So if I actually try, so I know if I hover my mouse over Ada, I should focus it, I know that the address of that computer is 10.10.10.0.0.10, and I hover over Hedy, it's 192.168.0.10. But if I actually try and ping, well, that is very small, and I don't know if I can zoom that in very well. So just bear with me a second as I just change my preferences so that screen is much better for you. So I'm just going to set the CLI font to a much larger, so that will reset. And then if I go in there again and do that, that's better. So if I ping 10.0.0.10, I know that it's not going to work. So it's telling me that destination host is unreachable. Just like Brian is saying, at the moment, it doesn't know where to send it. It's timing out. It's because there is no way it can get across the network. However, if I ping 99.0.0.2, which is, if I hover over here, the connection that the router has on the destination, on the route towards, it knows where it's going because it's connected to the router. But it can't get the whole way across the network. And that's because we need a routing protocol. We need a system like the post office to find our way around the network, a kind of router sat nav. To do this, it's not terribly difficult. We need to tell the routers about the network addresses that they can talk to. Now I'm going to do some configuration, and I've just enabled, can you see, I've got a little hash there, which is really helpful, isn't it? It's a tiny little hash. And then I'm going to configure terminal. And then I'm into the configuration mode. And then I'm going to do something called router EIGRP, Extended Interior Gateway Routing Protocol. It is a mouthful, but this is a routing protocol that Cisco use and others can use via open source access. And I'm going to tell it that it's going to be network 123. Why? Because all three routers need the same network ID so that they can talk to each other. And 123 is a really easy number to remember. So I'm telling that this is going to be the local postcode. So a bit like BA or MK or TA, as we sort of talked about, 123. And I'm going to tell it which networks that we're going to talk to. But I'm going to put in what's called a network address. So it's all zeros. So I know that locally connected near to my router on Lamar is the 99 and the 66 network. The network, oops, learn to type, Andrew.
I do that all the time.
We all do it. But then if I just type in end and just save the config, that will be fine. Now I go to Lovelace and I have to do exactly the same. So enable or ENA and then configure, learn to type Android terminal. I am using some shortcuts and then router EIGRP 123. Again, it's the same postcode or the same router autonomous system, the technical term. So I'm on Lovelace and I know that connected is 99 and 33. So network. I'm going to do 33 first because what you're going to see as soon as I do 99 is a message will pop up. Let's wait for it. There we go. They're talking to each other. So Lamar and Lovelace are already sending packets to each other, and they're sending what's called hello packets, literally because, and routers say hello to each other. And they do something, if you can see me on, they do something called a handshaking process, and they continually say hello to make sure that each other are connected, make sure each other are alive, and they're also telling each other about the network they know. So Lamar has just told Lovelace about I'm connected to 192.168.0.0. So we put that into the system as well. So what we now can do is go back to Lamar and enable configure terminal router ERGRP 123 and then tell it about network 192.168.0.0 and that will be sent all the way to Lovelace. And if I go to, oops, wrong one. If I go to Lamar and I do exactly the same, enable, configure terminal, and then network. Sorry, I've got to do router ERGRP first, haven't I? And then tell it about network at 10.0.0.0. Now they're talking to each other and they're telling each other about all of their postcodes. I can go over to Curie and do exactly the same. This is quite quick. Enable, configure terminal, network. So, oops, router, GRP 123. It has to be the same network. So, network 66 and oops. 6.0.0.0. There you go. It's hello. and it's done a term called convergence, or it's converged. And if I do network 33.0.0.0, it will do exactly the same. It's converged that way. So now they've created a circuit or a loop, and they've created a full mesh. So if you ever read in your curriculum about mesh topologies, this is the simplest mesh you will ever see. Three routers connected together. And then obviously I need to tell about network 172.16.0.0. And now they're all seeing each other. It can take minutes across a large network, a really large network. It can take up to 15 minutes to propagate, is a term, where it's sharing information across all the hops. Take 15 minutes across the entire planet. However, in our simple network, it takes seconds to propagate past the information across the network until it's fully converged, and every hop or every router knows about every router on the system. And I can prove that by doing a simple little command called show IP. So we're using the Internet Protocol routes, and it's actually showing the routing information across the network. And any entry that's got the letter D in it, D stands for EIGRP. It gets really techy, and I'm likely not going to explain why they use the letter D, but it's to do with the algorithm. So if any of you are doing A levels in computer science and are learning about finite state machines, then you're actually discovering a finite state machine in action. But that's just getting a little bit more advanced at this point. But we can see it sees 99, and we're on Curie, and we know it can see 99, and we could also see that it's not physically connected to 99. 99 is far away. It's actually learned about it from other devices, just like it's learnt about 192, which is far away on the other side of Lamar as well. So the system is converging and it's passing data around the network. So now if I go to Heady and go to the command prompt, and some of you may have learned, I'm actually using the up arrow, and I've just hit the up arrow twice on my keyboard, and a lot of command prompt systems, including Windows, allows you to do that. If I hit enter now, that shouldn't have done that, and I'm wondering if I've forgotten to put that into Lovelace. Yes, let's just do something. So I'm going to do some troubleshooting then. Do show run, and let's see if I've made a mistake. Ah, yeah, look, I've missed that out. It still doesn't know about it because of my mistake, but I can fix that very quickly by doing network 10.0.0.0 and right. And then if I go to Heady now, it's going to take probably about 15 seconds. It's the time for me to waffle and do that. Hit the up arrow. Let's see if it learns. It should have learned it by now. Okay, it doesn't like this. So why does it like this, Andrew?
Andrew's handwriting isn't good enough.
It's probably something like that, but let's end right, show, run. It didn't actually enter that, so let's do that again. Terminal, router, EIGRP123. It's good that you're seeing me make mistakes here. Network 10.0.0.0. And right, show run. So I'm just showing it now it's in. Obviously, it is me and my typing skills. I'm actually going to go to Lamar. Oh, yeah, look, I actually put it in the wrong device. And that's what the problem is. So let me do show run here. And what I can do is then do a configure terminal router EIGRP123. No network 10.0.0.0. Stop confusing it. So I'm fixing my own routing problem. Then WR, then do show IP route. And then suddenly, as if just by magic, it's learned it. So you can see where I made a mistake and put the wrong network on the wrong device, and now I have unerrored it, and I have now should be able to go back into here, and finally it should work. Let's see, it should possibly lose the first packet used to address resolution, and there it goes, yay. And Bryony is probably smiling, saying, yeah, I probably make those mistakes as well. But what I've done now is I've told all three devices that if I go to Mary, who we haven't touched and has been left alone, and I just type in ping 192.168.0.10, I can go to Hedy, straight away it knows the route. And if I go to 10.0.0.10, because Murray is going to go speak to Ada, we're able to send the packets as well. And they're routing quite comfortably around the network, so much so that I should be able to ping 99.0.0.1, which if I hover over here, I know it's the connection between Lovelace and Lamar on the Lovelace side, and that works as well. So bar the couple of errors I've done, you can actually configure this. So I'm actually going to save this as a slightly different version. So that you can have both available on the site. So basically now with Packet Tracer, I've built a rooted network, a complex system. I've used EIGRP. I've told it it's the postcode 123 or the autonomous system 123. The networks converged, bar a couple of typos that I made. The Hedy can speak to Lamar and Marie can speak to Hedy and Ada can obviously speak to Marie and Hedy as well. And the whole system is able to update and learn its way around using the EIGRP, the Extended Interior Gateway Routing Protocol that Cisco originally created a long time ago and has now made publicly available for everybody else. Bryony, do you have any questions or observations as I stop sharing?
I was going to refer to the routing table you were showing us as an address book, but I'm not sure the young people even know what an address book is anymore. They don't come through your door with a thud.
No, I remember the old, you used to get the old telephone, but it's kind of like your contacts on your phone, isn't it?
Yeah.
That's probably the best way to sort of describe it now. You need in network and an addressing table, and it's all the devices you know, or all the networks you know to connect to, and even your laptop and your smartphone keeps an addressing table, albeit a simple one, so it knows the devices that it's spoken to, and that's why you talk about something called the address resolution protocol. Your PC or your smartphone or whatever you use keeps a little table on its device where if you've sent traffic to a server locally or afar, it knows from whence it came and how to speak to it next time within a few minutes of any conversation that's had on the network. I get quite excited.
Yeah.
It's quite. Sometimes that's where we do it, and you can see where I made a typo by putting the wrong network on the wrong router. But I immediately started looking at the addressing tables, and then I looked at something called, when I typed in show run, I looked at the running configuration to see what was in memory that I put, and I could see that I hadn't typed what I thought I typed, and I typed it in the wrong place. And yeah, like a post person, I sorted out the routing problem across the network, very quickly. Embarrassingly as well, but very quickly nevertheless.
It just shows we all make mistakes. 90% of networking is fixing the problems you've made and be able to understand and troubleshoot rather than just knowing commands, isn't it?
It is, and one of the skills that we look for in the industry is your ability to problem solve. We're not, we're looking for people who will think and will solve problems. And a lot of cybersecurity experts are very good problem solvers, social problems as well as technical problems, and thinking their way around from just being able to make the thing isn't good enough. You've got to be able to think about the thing and work out the problems. And Brian and I were judging at some skills competitions last week in Manchester. And I would say probably the biggest talent we look for is problem solving.
Yeah, definitely. It's not about a person who sits there and has all this bank of information because you don't know everything anyway. It is about that ability to take a problem and look at it in a different way and solve it. And then if you make a problem from that, how are you going to fix it? And it's always nice to see the competitors doing that, isn't it? Especially in ways you might not always see. I'm sure you had an example last week of a way of solving a problem you hadn't seen before.
Yeah, I can't go into the details, but let's just say myself and another judge took a photo of it for our own professional development. And this is a young 17-year-old who did a really interesting thing. And, even us older individuals now the kids like, aha, that's really clever, that is. And yeah, we'll go off and learn from that for our own benefit and improve our own professional skills. All right. So thank you very much, Bryony. Thank you very much, everybody else. I'm going to stop the recording now.